Expectation versus reality. We all have our expectations, but sometimes things don't go as planned. So instead, we get reality. I know, it's not that comforting. You could say that scientists go through this every time they test their hypothesis.
That's kind of what happened in the ultraviolet catastrophe. Laura Riley and James Jeans were analyzing blackbody radiation. From it, they developed a formula. And you might be thinking, well, problem solved. But after they made the experiment and saw the results, they noticed something. The results differed drastically from their analysis. Theory was far from reality. Something was missing. We'll go more into detail later. First, let's explain a few concepts.
What is a black body? A black body is an object that absorbs all wavelengths of light, making the body appear black, hence the name. However, this is an idealization, as a perfect black body does not exist in nature. A practical example of a black body would be a box, with black interior walls and a small hole. All the radiation entering through the hole would be absorbed inside, with only a negligible part escaping. Now, what is blackbody radiation? This is the energy radiated by a black body. Pretty self-explanatory, right? Now, let's go more into detail. You have a black body. At room temperature, this body is glowing, but we cannot perceive it with our eyes because it's in the infrared region. Now, this black body absorbs light, causing it to heat up. If the body heats up enough, then it will start to glow, from red to yellow to white, as the wavelength approaches the visible range. The same way a kitchen stove starts to glow as it gets hotter and hotter. Now this is the spectrum distribution of blackbody radiation, and this is what the physicists in the 1890s were studying. Here's where the ultraviolet catastrophe developed.
Physicists developed expressions to predict this distribution. Wilhelm Wien came up with a formula that corresponded well with the experiment, but didn't have a satisfactory theoretical foundation. Then Laura Riley and James Jeans presented what is still known as the Riley-Jeans formula. However, there was a major problem with this one.
As the wavelength entered the ultraviolet region, the intensity approaches infinity. This differed completely from the experiment, that showed that intensity had a maximum value in the ultraviolet range.
This is quite a shock!
A black body cannot emit infinite amounts of radiation because it will violate the law of conservation of energy. This law states that the energy can neither be created nor be destroyed, and by emitting infinite amounts of it, it will be creating energy out of nowhere.
This is the worst!
It was indeed a catastrophe. By then, Max Planck had already been working on figuring this out. He eventually recurred to a trick to make the math work. He stated that a black body could only emit energy in discrete quantities, or chunks.
He established that the energy equals to a constant h, now known as Planck's constant, multiplied by the frequency of the light emitted. And it worked. The theory now matched the experiments, and the ultraviolet catastrophe was solved. And it would eventually lead to the development of quantum mechanics.